Okay, next we are moving to the previous year question paper explanation from chapter number 2, resistive circuits. So still now we completed the theory part. We are already uploaded in our mobile app. So based on that we are going to discuss about the previous year questions. So here the first question from 2018 question paper. The equivalent resistance seen between P and Q will be. So you should find out the equivalent resistance between these two terminals P and Q. So while you are locating this particular circuit diagram, it is like a complicated and big circuit diagram. But in the examination, we have a 1 minute time, right? In this 1 minute time, how to attempt the question, I will explain you. So first of all, some basics related to the open circuit. In case of open circuit, what about the current flowing? Zero. Whenever there is no current flowing through the particular open circuit, that particular element is neglected. For example, resistance is neglected if in case of open circuit. If you know that particular concept, coming to here. In this case, the 5 ohms resistance is neglected because it is open circuited. Here this 5 ohms is neglected, it is open circuited. Again, this 20 ohms neglected, that is open circuited. Clear? So whenever those are open circuited, then we are moving to the remaining part of the solution. These two are parallel, right? These two are parallel. I am going to give the one shortcut to you. Whenever equivalent resistances connected in parallel, whenever equivalent resistance connected in parallel, resistance, one of the resistance divided by 2 is a total resistance. So here 30 and 30 equal resistance, right? Parallel. So 30 by 2, 15 ohms is a value here. This 15 ohms series with the 5, that is equal to 20. So still we got total entire combination, we got 20. Clear? Now again this 20 and then this 20 in parallel. So again 20 same equivalent resistances. So it's 20 by 2, that is equal to 10 ohms, right? So now this is these two equivalent is 10 ohm. Okay, whenever parallel R by 2. Now finally we have this particular combination, this particular branch final resistance is 10 ohm. Now this 10 ohm and this 10 ohm connected in series. Okay, I will make another color. This 10 ohm and this 10 ohm connected in series. So finally those are connected in series. See here, connected in series, R equivalent is equal to 10 plus 10, that will be equivalent to 20 ohms. Now you got this total entire combination is 20 ohms. Now this 20 and then this 20 in parallel. Okay, so again equivalent resistance is parallel, 20 by 2, that will be equivalent to 10 ohms. Finally what is equivalent here? 10 ohm. The 10 ohms and this particular 10 ohms connected in series. So finally RPQ is equal to 10 plus 10, 20 ohms. This is the final result. So 20 ohms is the answer. You got my point? In case if you are in the theory class, I explain more than 5 or 6 problems based on the series and parallel combinations. If you are perfect on those problems, this type of questions easily can solve. So you know how to find out the solution without drawing any redraw the circuit and remaining thing. Just apply the common sense. For your understanding purpose, I am using different colors, right? So I have not drawn each and every step here because you are attending the objective exam. That's why your preparation should be in this manner only to find out the solution. Okay. Next we are moving to the second question. That is a question from 2017 question paper. So here for the network shown in the figure, the value of Vs, which makes to I naught is equal to 7.5 milliamperes. So I naught value is a 7.5 milliamperes. 7.5 milliamperes. So once this is a current, this is the resistance, you will get this voltage, right? What is voltage? V is equal to IR, 6 into 7.5. That will be equivalent to 45 millivolt. So clear? What is voltage now? Here voltage is 45 millivolt. Once it is a 45 millivolt, what about the current here? The current 7.5 milliamperes, because this is a current is 7.5 milliamperes. This is a 6 ohm resistance, this is the voltage is same for both. That means definitely here also 7.5. Once again I will repeat, by the inspection method, this is the resistance is 6 ohm, this is the resistance is 6 ohm, this is the voltage across, this one is a 45 millivolt, it is a parallel, right? Here also 45 millivolt, definitely current is same. Here mentioned 7.5, here also 7.5. So according to KCL, incoming current is equal to outgoing. These are two are outgoing. What is the incoming current here? The incoming current here 7.5 plus 7.5, that is a 15 milliamperes. So now carefully listen. These two are the combination. You need to find out the voltage. V is equal to IR, 4 into 15 milliamperes. That will be equal to 60 millivolt. You got here 60 millivolt. So once you got here 60 millivolt plus 45, because your voltage drop plus you are come back to the circuit, right? 60 plus 45. So now here 105 millivolt. Once this is a 105 millivolt, you can find out this current, right? That current you can find I is equal to V, 105 millivolt divided by 7. That will be equivalent to 15 milliamperes. So what? Here 15 milliamperes. So in this case you got here 15 milliamperes, here also 15 milliamperes. Total is equal to 30 milliamperes. So you got 30 milliamperes there. So once you got this is a 30 milliamperes, definitely can see, you can find out this voltage, right? This voltage is equal to V is equal to 30 milliamperes into, what about the resistance? This total combination resistance is 8 plus 12, that is equal to 20, that is equal to 600 milliamperes. So what is a millivolt? What is the voltage now? 600 millivolt. Already here 105 plus 600. So finally Vs is equal to 600 milli plus 105 milli. That will be equal to 705 millivolt. What is the answer now? D. Option D is the correct option. So all of you got the idea how to find out the values. You can come back to our destination point, starting point. Then you will get the voltage. This is the way you can find out the solution. In the exam, if once you practice more for your explanation, for your understanding purpose, I am explaining slowly step by step. If you practice more and more problems, if you listen more and more classes in our mobile app, definitely we can find out the solution within a fraction of seconds. Okay. Next question. This is a question from 2016 question paper. In open circuit, current through it is, in case of open circuit, current will be 0. Current is 0. What about voltage is unknown. So in case source voltage you don't know, so voltage is unknown. So option A is correct. Just verify the remaining options. Current through it is now? No. Voltage is 0, not. What about here? See, current through it is 0, but Voltage is 0. It is wrong statement. It is correct, but it is wrong. Coming to here, unknown, no. Voltage is also unknown. Okay, it is also correct, but this statement is wrong. Finally, what is the statement correct? 0 and voltage is unknown. Next. We are moving to the fourth question. This is the question from 2016 question paper only. Which of the following is true about two resistors connected in series? Okay, let me take two resistors here. Okay, connected in series. So what happened? What are the statement? Look at here. Both the resistors carry the same amount of current. Just look at the circuit. Current will be delivering from here. The same current is flowing R1, the same current is flowing R2. This statement is correct or not? Yes. Coming to the second statement. In the second statement, total resistance equal to sum of all the resistances. Yes. R is equal to R1 plus R2. So second statement is correct. Sum of the individual voltages IR drops equal to applied voltage. Yes. For example, these are the V1, these are the V2. So supply voltage V is equal to V1 plus V2. Yes. So that means all of the above. So option D is the correct option. So answer is all of the above. Next, question number 5. This is the question from 2016 question paper. So in the examination, some of the questions are difficult questions, some of the questions are moderate questions, some of the questions are easy questions. Okay, that is a pattern of exam. If you are prepared thoroughly, all the practice, all the problems, as well as difficult concept you learn, definitely can crack your exam. So coming to here, which of the following is false about three unequal resistors connected in series? That means here see R1, R2, R3. Three unequal resistors connected in series. Right. Voltage across each branch is same. Voltage across each branch, here V1, here V2, here V3. That means voltage across each branch is not same. Right? This statement is wrong. Reciprocal of the net resistance of the entire circuit equal to the sum of the reciprocal of the individual resistances. That means, reciprocal in case of net resistance, R is equal to R1 plus R2 plus R3, not reciprocal. Reciprocal only in the parallel circuit. This statement is wrong. All of you following? If in the theory class I explained formulas and then characteristics, everything clearly. Just go to our mobile app, you can see these videos. Definitely, all these concepts are explained properly there. Next, third one. Sum of the individual branch currents is equal to the total current supplied by the battery. No, current is same here. Current is same. So, all branch currents are same. So, see here, current in each branch is equal. Yes, this option is correct. So, finally, which one is correct? Option D is the correct option. Current in all branches are same in case of series circuit. Okay. Next, question number 6. Here, 2014 question paper. The voltage division and current division forms a dual pair. Both are dual pair. Okay, next we are moving to the question number 7, 2014 question paper. This is the last question from here. Two identical resistive loads consume a total power of W watts when connected in parallel across ideal DC current source. That means two identical resistive loads. Here current source is there, I. Two identical resistive loads. Two identical resistive loads consume a total W watts when connected in parallel. So these two are parallel. Right. So W. So total power consumed, the two identical resistive loads consume total power W watts when connected in parallel. So let me take this is a P1, this is a P2. Total power is equal to P is equal to P1 plus P2. That is given W watt, right? Now, what would happen the consumption if they are connected in series with the same source? If they are connected in series with the same source, right? What will be the power? So in case of series or parallel, the power is combination P1 plus P2, that will be W watt only. So there is no change in power consumption whether there is connected in series or parallel. The wattage is same. Which one is correct? It would be remains same. So option A is a correct option. So this is about the explanation about these 4 question papers 2014, 16, 17 and 18 question paper from chapter number 2. So those are interested to learn the concept of all KVS TGT work experience teacher syllabus, each and every topic available in our mobile app. Still we completed unit 1, chapter 1, chapter 2, 3, 4, 5. 5 chapters still up to date completed, and 6th and 7th units are I'm making the content, making the video, creating the video content at present. So according to our schedule given in the previous video, 30th of December I will finish total entire first unit with including test series and the previous year's question paper explanations. Thank you.